Hi there. In this video, we are looking at the source code of the StyleCLIP. My repository provides an unofficial tutorial video and source code. With StyleCLIP, we can easily manipulate an image by using our own text prompt. For example, here is a source image on the left side. Then we can generate the right side image using a text prompt. A really sad face. When I set the number of optimization steps as 150, the morphing animation that contains 150 frames is as follows. As you can see, the expression of the smiling face is gradually changed to a sad expression. If you are interested in more detailed explanation for this paper, I recommend you to see my video StyleCLIP Explained on my YouTube channel. Now we are going to run the source code of the basic latent optimization method. I made this source code referring to the original source code provided by the authors. Let's click the Google Colab tutorial source code, and then click the button Open in Colab. First of all, we need to install the CLIP library that has been proposed by OpenAI. CLIP is a large model that jointly trains an image encoder and a text encoder using a large dataset. The CLIP can be used for calculating the similarity between an image and text. It is noted that if an image and text features has similar semantic meanings, the cosine similarity between an image and text feature is high. This installation could require several minutes. We then load the pre-trained StyleGAN model. StyleGAN is an efficient architecture to generate high-quality images. We can produce a high-quality image by propagating a latent vector into the StyleGAN model. I have uploaded the weight of the pre-trained StyleGAN V2 model to my OneDrive for this tutorial. By running these source codes, you can download the weight of the model and initialize the parameters of the generator. We then define the clip loss function. This implementation of a clip loss calculates the similarity between an image and text. We can do the backpropagation and calculate gradients from this loss function because it is differentiable. So how can we optimize a latent vector using a CLIP and StyleGAN? StyleCLIP optimizes a latent vector in a way that embedding of the generated image is similar to a given text prompt. For example, if we set the text prompt as without makeup, this woman image will be updated in the direction of semantic information for without makeup. Now let's produce a manipulated image. First, we can make a latent vector by encoding a source image to a latent vector or sampling a latent vector. The mean latent can be used for generating a statistical average face. We can produce a more realistic random face by truncating a latent vector. The truncation trick constrains the generated image to be close to the average face. It is noted that the generated image has high resolution, that is 1024 by 1024. For visualization, we downscale and display the image. Okay, the basic method of the StyleCLIP is a simple method utilizing a gradient descent to update the latent vector. For the text-driven manipulation, this optimization method combines the clip loss and the latent encoding loss. The objective function consists of three terms. The key factor is the first term. While we encode an input latent, we can also optimize the encoded image to have similar semantics to a text prompt at the same time. In this paper, the authors say that this optimization method requires more than hundreds of iterations for generating a manipulated result image. Now let's manipulate the previously generated image. You can set the argument for the latent optimization. The two key arguments are description and L2 lambda. The description denotes a text prompt used for a clip. According to the objective function, the L2 lambda parameter controls the similarity to the input image. The higher value of L2 lambda, the strong constraint is applied. If your text prompt does not work properly, I recommend you use the lower value of L2 lambda. The authors use the running rate adjustment. We update the running rate gradually instead of using a fixed running rate. We tokenize our text prompt and forward it into the clip model. We use the Latent Optimizer and update the latent vector. We set the number of iterations as 150 by default, and this optimization process is similar to the normal optimization process. For every iteration, we first adjust the running rate and then calculate the loss values using the generated image and text prompt. Finally, we update the latent vector after backpropagation step and the gradient calculation step. This whole optimization process requires about 3 minutes in the Google Colab environment. The result is as follows. You can download the video that contains a morphing animation between the starting generated image and the manipulated image.